Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. So today we will try or experiment and Wien Bridge Oscillator, which is the last experiment, experiment number 8. Okay, so the objective is we want to see the operation of Wien Bridge Oscillator as it will using the feedback, okay, feedback to as an input of the op-amp. Alright, so there are a few design of the Wien Bridge Oscillator, but basically it will have R and C. So the output of this experiment is the oscillation. Okay, so it will generate a sinusoidal wave. Okay, so to measure the frequency of the sinusoidal wave, we will use this formula. F equivalent to 1 over 2 pi square root R1, R2, C1 and C2. Okay, so this RC network will be using if we are using the same R1 and R2, so we'll just name it as R, and as C1 and C2 is the same, we will just name it as C. So we'll remove the square root, so it become 1 over 2 pi RC as the frequency. Okay, so we can know what is the frequency of the oscillator. We can also have the gain as the op-amp will generate amplifying. So the gain can be measured as 1 plus RF divided by R3. So here is the RF. RF is the feedback. Okay, the feedback resistor. Okay, and then R3 is the actually is in the real lab is a potentiometer, but in the simulation we will have to make sure that the value of R must be equal or more, but not so high. Okay, sorry, this is RF divided by R3. Okay, so the value of this gain must be for the Wien Bridge Oscillator must be 3. Okay, the ideal one. Okay, later you will see what happen if it's more or less than 3. Okay, so for example, if you choose here 2, okay, and here is 1. Okay, so 2 divided by 1 is 2 plus 1 is 3. So should be fine. Okay, so as long as you will get the gain of 3. Okay, so this is R1 and R2. Basically the R and C is in series here and parallel here. Okay, so these are the two feedback network, RC network. Okay, so it feedback to the input 2 as the negative feedback. Alright, so here you can see that the simulation in PSpice. Okay, so this is RF, okay, and R3. So you can actually adjust this value in order to get the gain as 3. Okay, so maybe here you can change to 2.2. Okay, see what happened in the graph. Actually, it will give different values and different oscillation if you change this value. Okay, make sure the AV is equivalent to 3. Yeah. Okay, so the output is measured here at the output of the op-amp, and the input is here. Okay, so be careful of the symbol plus and minus, because this one different from the circuit diagram. Okay, so for the initial condition of the capacitor, put 1 amp. Okay, for that one, and then you can put the analysis as transient, and to make sure that you can see the signal, okay, can be seen in one cycle. So you should calculate what is the F. Okay, calculate F and then find the T. Okay, so once you have calculate F, 1 over 2 pi RC. Okay, and then you can find t. Okay, so the time t here, if you put only t, it will show only one cycle. But if you want to see 10 or 5t, so you put here 5 multiplied by t in the setup analysis of the transient. Okay, so don't put like so many, so that until that we cannot see any oscillation. Okay, put some limited value, at least 5 or 10 time of the period of the oscillation. Okay, so this is the graph. If you put the AV equivalent to 3, okay, so the output somehow 3 and the input almost 1, so 3 divided by 1 is 3. Okay, so theoretically we need the value of the RF and R3. Okay, so this is the experimental value and this is the theoretical value. Okay, so the phase also the same, okay, in this experiment. Okay, from this one also you can check the frequency by measuring from one peak, okay, or one complete cycle, or maybe from here one peak to another peak. This is t. Okay, so from t you can calculate the frequency, or you can just use the frequency spectrum analysis domain, so you can plot the frequency from here. Okay, you can either use either these two methods to show the frequency. So you can see that 14 hertz, okay, for low frequency oscillation. So basically the Wien Bridge Oscillator is used for the low frequency oscillation. Alright, so then you have to change the value of the capacitor and find the frequency, phase, is there any phase difference, V in, V out, and also the gain here. Not yet the gain here, but RF divided by R3. Okay, and then the gain we know just now I have mentioned, V out divided by V in, and the theoretical can be 1 plus RF divided by R3. So here you have to play around with the value of RF and R3 until you get 3. Okay, so this is what happened if you put the RF divided by R3 less than 3. Okay, less than 3. So it will oscillate, but it will goes to 0, or the signal will be damped. It's not stable oscillation. Okay, so that's why we have to take some threshold 3. Okay, and then if you put more than 3, okay, maybe 4 or 5, so the signal will be cut here, not a perfect sinusoidal. Okay, so we don't want also like this. So I hope you can shows what happen if different value is used in the experiment or the simulation. Okay, so that's all for the simulation part. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.